Assalamualaikum. We are Group E2 from EMT 3323 Engineering Design. Today we are presenting our project Robocar. It is a small robotic bicycle designed to be strong, lightweight and efficient. It is made to ensure good stability, durability and smooth performance. This project combines simple mechanical design with basic engineering idea to create a functional and attractive robotic platform. The first objective is to build an RC robot soccer car using BBC micro:bit. The robot can be controlled wirelessly and used for soccer activities. Next, objective 2. The second objective is to create a fun STEM learning platform. It helps students learn programming, robotic and problem-solving skills in a more interactive way. Next, the problem statement. Programming and robotic skills are becoming more important. However, many students do not have enough hands-on experience because learning is mostly focused on theory. Besides that, some robotic kits are expensive and not easy for beginners to use. Therefore, this project developed an RC robot soccer car using BBC micro:bit as a simple, affordable and interactive to help students learn programming, robotic and problem-solving skills. First of all, the design process started with sketching and modeling Robocar using SolidWorks software. Through CAD modeling, the dimension, structure and overall shape were optimized, balance, stability, strength and functionality. SolidWorks also allow to visualize the full assembly, check component placement and improve the design before publication. This approach ensured the final design was practical, efficient and meet the project requirement. So for the material, we use an epoxy composite. It was chosen because it is strong, lightweight and easy to fabricate. Epoxy also has good rigidity and durability, which make it suitable for supporting the Robocar structure and improve its overall stability during movement.
Weight process. In this step, the epoxy resin and hardener were weighed using a digital weight scale. The correct ratio between the resin and hardening is very important to ensure proper curing and good mechanical properties. Therefore, both materials were carefully measured according to the recommended mixing ratio. Accurate weighing helps produce a high quality epoxy sample and reduce the possibility of defect during the curing process. Mixing process. After weight, the epoxy resin and hardener were mixed in a clean container. The mixture was stirred slowly and continuously for several minutes until a uniform and homogeneous mixture was obtained. Proper mixing is important to ensure that the resin and hardener react completely during the curing process. This step helps improve the quality, strength and durability of the final epoxy sample. Pouring into mold. After the mixing process was complete, the epoxy mixture was carefully poured into the proper mold. The pouring process was carried out slowly to minimize the formation of air bubbles that could affect the quality of the sample. The mold was then left undisturbed to allow the epoxy to cure and harden properly before future testing and evaluation.
So next, the body of Robocar is made using aluminium, which provide high strength heel, keeping the bicycle lightweight even though it is compact. The structure is still strong and durable. The wedges shape from help improve pushing performance. The upper layer protect the internal components and give a neater appearance. The lower layers act as a main support platform to ensure stability. At the back, the spoiler improve the overall look and makes the design more modern and attractive.
Here, we are assembling the electronic component of the RC robot car. The battery pack supplies power to the system, while the micro:bit acts as the main controller. The servo motor are connected to the micro:bit through jumper wire and connector. After completing the wiring, we verify all the connection to ensure the motor could receive signal correctly. This setup allows the robot car to perform the programmed movement during operation. First, we developed the coding for the RC robot car using micro:bit. We use block-based programming to create movement commands such as forward, backward, left and right. Instead of using a wired connection, the robot car is controlled through a wireless Bluetooth application connected to the micro:bit. After completing the coding process, the program was uploaded and prepared for testing. After completing the coding, we tested the robot car using the Bluetooth control application. We checked whether the car could move according to the command given through the apps. The testing focused on movement accuracy, response time and connection stability. The results showed that the robot car responded correctly and performed all programmed movements successfully. Finally, we conducted a soccer match test using two RC robot cars. The objective was to evaluate the car performance in a real game environment. We observed the car speed, maneuverability, control accuracy, and ability to push the ball toward the goal. The test demonstrated that the robot car could function effectively in a soccer game while applying concept of robotic programming and STEM learning. First, the sample were cut into the required dimension to make the tensile test easier and to ensure accurate result. 3 samples were prepared, namely sample A, sample B, and sample C. Each sample was then mounted on the tensile test machine and could anti-failure accurate. The test was conducted to determine the tensile strength and mechanical properties of each sample. By comparing the result of sample A, B, and C, we can evaluate the consistency and performance of the material.
Next is the tensile test. The purpose of this test is to determine the tensile strength and mechanical performance of the epoxy sample. During the test, the sample was placed in a universal testing machine and pulled from both an anti-failure accurate. The tensile test help evaluate the strength, stability, and suitability of the epoxy material for engineering application.
Next, we conducted a tensile test on 3 samples to measure the strength of the Robocar body material. The average force recorded was 181.63 Newton. Sample 3 showed the highest strength with a value of 260 Newton. Based on this result, the material has good strength and is acceptable to be used for the Robocar body.
This slide shows the optical microscope observation of our sample at 3 different magnifications, time 5, times 10, and time 20. At time 5 magnification, the overall surface structure can be observed, including visible scratches and surface irregularities. At time 10 magnification, more detail of the surface become clear, showing the distribution of pores and defects. Finally, at time 20 magnification, the microstructure is observed in greater detail, where smaller pores and surface fracture can be identified more easily. Based on this observation, the sample surface contains scratches and porosity, which may have formed during the fabrication or preparation process. The increasing magnification helps us analyze the surface characteristics more accurately. The testing results showed that the RC robot car responded successfully to the command sent from the controller. The car was able to move forward, backward, left, and right with good accuracy. During the soccer test, the robot car could push and control the ball while competing with another car. However, slight delay in movement occasionally occurred due to wireless communication and battery performance. Overall, the project achieved its objective of developing a functional RC robot car soccer system using micro-technology.
Lastly, in conclusion, Robocar achieved design goal with good strength, functionality, and structure. In the competition, our team won first place among the group. This showed that our design process and material selection were successful.